Okay, so continue on. Optimization problem. This is the one I said in class that make sure that you know how to find the circumference. Well, actually, I said it in third period, but make sure that you know circumference formula. Circumference is 2 pi r. There's a question about that involves the sum like SUM, of height and circumference. So that would really be h plus 2 pi r. And then it will give you something else in the problem. Make sure that whatever you're optimizing, whatever is the, like whatever you are, I guess optimizing, finding the least or the most of, whatever that is, whether if it's the greatest area, you set the derivative of area equal to 0. If it was the greatest volume, you set the derivative of volume equal to 0. So any of those problems. The next thing, it says find the average rate of change for velocity or acceleration given position. If you're given position and you want velocity, this will give you velocity of some value, v prime of t. Well, at least the average, or it's going to be approximating. If you want acceleration, that's a little bit different. So if I wanted acceleration, sorry, I shouldn't have said v prime. Sorry, this is just v of t. It would be p prime of t or v of t. This would be velocity. If I did acceleration, that would be p prime of v minus p prime of a, because that's the same thing as this. V of b minus v of a. This is going to give you acceleration, or v prime, or at least approximate it. This would be the average rate of change. If you're finding the instantaneous rate of change, if I want velocity or acceleration given position, velocity is just p prime. Acceleration would be p double prime, which is the same as v prime a of t. Make sure that you know those connections. Okay, this thing, the graph of velocity and acceleration are given below. So this is a little bit different than we usually write it, because usually we say the intervals like 0 to 1, 1, 1 to 3, 3, 3 to infinity. This one is saying there's something happening at 0, 1, and 3. So same thing down here. I'm going to put 1 down here, and 3 down here, and 2 up here, so that I'm talking about the exact same intervals. This says, what do I know about the particle? I know the particle is moving left when velocity is negative. So the whole way from 0 to 3, from 1 to 3, because this is saying velocity is 0 at those values. So from 1 to 3, I know the particle is moving left. From 0 to 1 and 3 to infinity, I know that it's moving to the right because velocity is positive. Acceleration, I can see when it's negative, when it's positive, so I know velocity is decreasing here, increasing here. Acceleration is negative, acceleration is positive. So from 0 to 2, velocity would be decreasing. From 2 to infinity, velocity would be increasing. But it's also saying increasing speed. Speed and velocity have to have the same sign if a particle is going to be increasing speed. So you see right here, so from 1 to 2, they have the same sign, increasing speed. 3 to infinity, same side, increasing speed. Opposite signs, that's when it's decreasing speed. So you're paying attention to those intervals. Okay, this one's saying f prime of c equals 0. We've got this differentiable function, which means it's continuous. So lots of theorems apply. It says f prime of c equals 0, so I know something about, it could be rules, it could be MVT, but it doesn't have to be. And then it also says f of 7 is less than f of c. So then it's got me thinking about just function values. So this could be extreme value theorem or IVT. So I'm going to go through this and just kind of put what I know. It's differentiable, so it's doing something, it could be going up and down, but it's nicely, like there's no sharp turns. It also says that f of 7 is less than f of c. So I'm saying 7's here, c is somewhere in between, -2 is over here. Well, that's really to scale, but whatever. F of 7 is less than f of c. So if f of 7 is here, f of c would be here. It can be moved anywhere. I don't know anything about f of -2. As soon as I start seeing here, all of these deals with absolute maxes and minimums, except for this one. It says f prime of x is less than 0 on this interval from c to 7. It looks like it's going down, which is fine, but it could be doing something crazy and going up and down. So it can't be that one. Next one, it says, I'm going to go backwards. F of c is the absolute minimum. right here I can see f of c is higher than f of 7, so it's definitely not that. Either f of c or f of 7 is the absolute minimum. F of 7 could be, f of c is not going to be. F of negative 2, though, could be down here, so it can't be that. Remember, extreme value theorem, it's going to have a maximum and minimum, absolute minimum if the function's continuous. That's true in this one, but it could be at endpoints or where the derivative is 0. Next one, f of 7 is the absolute maximum. Nope, could be a minimum, but it's definitely not a maximum. Only one left, but f of negative 2 or f of c is the absolute maximum. That could be an absolute max. This one could be, because they happen where the derivative is 0 or where f of negative 2 at the endpoints. So A is the only possibility. The next one, I need to grab another piece of paper because that one bled through. So let's do this. On the back, it says the graph of the particle's position is given to left. So it says the x of t over here. I'm going to write it bigger to make sure I know. When is the particle moving right, moving left? When is the velocity increasing, decreasing? Okay, so when particles moving right, when velocity is positive. Or I could say when x prime of t is greater than 0. That means x of t is going to be increasing. And I can see that that happens from 1 to 5. Moving left would be when v of t is less than 0. X prime of t is less than 0, that is. So x of t is decreasing. And make sure you can still see this. There you go, decreasing. So that would happen from 0 to 1, 5 to 6. This one says, when is velocity increasing, decreasing? So velocity is increasing when a of t, acceleration, is greater than 0. Its derivative, v prime, or in this case, a of t is the same thing as x double prime of t. So if I'm thinking about x double prime of t being greater than 0, that means x of t is concave up. Sorry, it's hard to see. Concave up, around here somewhere. Kind of even looks like it stops there. So like 0 to 2. Same thing, velocity is decreasing when these are backwards. So acceleration is less than 0, x double prime of t is less than 0, x of t is concave down. So from 2 to 6. Okay, this one, you can see that they're given the same graph. You're given this graph of f, so I'm going to label it. What do you know about f prime and f double prime? F prime is going to be, so f prime and f double prime. If this is a graph of f prime is going to be positive when f is increasing. So I can say here and here. So f prime so from negative infinity to 0, 2 to 4. And then I could do the other one too. F prime is less than 0 when f is decreasing, and I could say from 0 to 2, 4 to infinity. I could also say f double prime. If this is f double prime, that's talking about concavity. F double prime is greater than 0 when f is concave up. When f is concave up, and I can see that it happens like from here to about here, 1 to 3, and then that's going to be it. F double prime is greater than 0 when f is concave up. That also, I know f double prime is greater than 0 when f prime is increasing. So I've got all these connections. So that would be on that same interval. And then it would be backwards. F double prime is less than 0 when f is concave down, which happens from negative infinity to 1, 3 to infinity. If I have a graph of f prime, though, it changes things up a bit. So f prime, when f prime is positive, that means f is increasing. So same relationship that happened up here, but totally different places on the graph because this is a graph of f prime. So f prime is greater than 0 when f is increasing, and I can see f prime is greater than 0 from negative 1 to 5. And then you could also say f prime is less than 0 when f is decreasing. That would happen from negative infinity to negative 1, 5 to infinity. I could also say f prime is increasing, here to here, here to here, negative infinity to 0, 2 to 4. If f prime is increasing, that means f double prime is positive, which means f is concave up on those same intervals. There's all sorts of connections, and then you could do the opposite, you know, similarly with f being concave down when f prime is decreasing, which would happen from from 0 to 2, from 4 to infinity. So all these connections. So other things that you should know, just looking through, really pay attention to those graphs that, if I'm talking about non-calculator tomorrow, the graphs where there's f prime, g prime. If you have a differentiable function, what does that mean? Also, this came up in the other class, but let's say you have a function like this, g of x is equal to the third, something like that. Make sure when you take the derivative that you're doing the chain rule, because wow, there's a function within a function. If you were asked to find the equation of a tangent line, make sure that you find the equation using this point, like that's your y value, put an x in here, figure out that point. Your slope would be this point if you're talking about a tangent line to g of x. Make sure that you know your theorems really well. On the next test, we went through a lot of this. Yeah, I think we did a whole lot of those. Remember, for Rule's theorem, if you're talking about intervals of time, let's say you have a chart. I've got x hours, minutes, whatever it is, and I've got some function f of x, and I want to know when can rules be applied, or on how many intervals, I guess. And I had 5, 6, 6, 5, 8, something like that. I would say rules could be applied here because a function is continuous and differentiable. I would have to tell you that. But you can see f of a equals f of b here, and then there'd be another interval right here from 0 to 3. And I think that's about it. Make sure that you know all these things we talked about as far as speed, velocity, acceleration, all the good stuff. Be safe, study lots. Email me with questions if you have them. Thanks. Bye.